Hello, welcome back once again. Today we're going to deal with complex numbers with imaginary power. We have 1 plus I raised to the power of I, and here we're going to find the real parts. Very interesting, right? Okay, so let's get started. First, let us recall that the square root of I, the imaginary unit, is equal to 1 plus I divided by the square root of 2. This is a cool idea which we're going to use to solving this problem. Okay, so now 1 plus I raised to the power of I is same as, we can do the following: square root of 2 raised to the power of I divided by square root of 2 raised to the power of I, and then multiply by 1 plus I raised to the power of I. So this is equal to square root of 2 raised to the power of I times 1 plus I raised to the power of I divided by square root of 2 raised to the power of I. Now we use this property. We know A raised to the power of M divided by B raised to the power of M is equal to A whole over B whole raised to the power of M. So remember, we have the same power, so this will become 1 plus I divided by the square root of 2 whole raised to the power of I. We can see that inside here, okay, we have square root of multiplied by square root of 2 raised to the power of I, so sorry for that. So we can see that inside here we just have the square root of I, as you can see from here. So therefore inside we just have square root of I, then raised to the power of I, then times square root of 2 raised to the power of I. Amazing. Again, inside the bracket, that is same as I raised to the power of 1 over 2, then raised to the power of I, multiplied by square root of 2 raised to the power of I. Again, let us use this idea. We know A raised to the power of B in bracket raised to the power of C is equal to A raised to the power of C raised to the power of B. So here, using this idea, this becomes, here, this is going to be I raised to the power of I, then the 1 over 2 outside. And then this is multiplied by square root of 2 raised to the power of I. Now, let's recall that I raised to the power of I is equal to E raised to the power of negative pi all over 2. So therefore, this is going to be equal to E to the negative pi by 2 raised to the power of 1 over 2, multiplied by 2 raised to the power of 1 over 2, that is the square root of 2. Right, so 2 raised to the power of 1 over 2, and then raised to the power of I. So this is equal to E raised to the power of negative pi by 4 multiplied by 2 raised to the power of I all over 2. Again, let's use this idea. Oh my God, so many identities, right? So A raised to the power of B can be written in the form E raised to the power of B times the ln of the base A. So this is equal to E to the negative pi by 4 times E raised to the power of I over 2 times the ln of 2, which you can write as E raised to the power of negative pi by 4 times E raised to the power of I, and then in brackets ln of 2 divided by 2. We're almost done. Then let's call upon Euler. Remember from Euler that E raised to the power of I of theta is equal to the cosine of theta plus I sine of theta. Therefore, this is going to be equal to E to the negative pi by 4, right? Then into bracket, that will be the cosine of ln of 2 divided by 2 plus I sine of ln of 2 divided by 2. Then open up the bracket to get E to the negative pi by 4 cosine of ln of 2 divided by 2 plus I E to the power of negative pi by 4 sine of ln of 2 divided by 2. So we can see now we have this is the real part and we have this as the imaginary part. So therefore we can say real part of 1 plus I raised to the power of I is equal to E to the negative pi by 4 times cosine of ln of 2 divided by 2, right? Which is approximately equal to 0.428829. Thank you for watching. If you enjoyed the video, kindly subscribe. Also like, comment, and share.